Okay, here I'm going to show you how to do problem 13 in chapter 5, page 145. This is a problem that I get questions on a lot, so we're just going to review this problem here. So in this problem, we're given a few things. As I read here, I see that heating 235 grams of water from 22.6 degrees Celsius to 94.4 degrees Celsius. So the mass of my water is 235 grams. The water gets heated, and I'm just writing down the knowns, the things that I know. The water is heated from 22.6 degrees Celsius to 94.4 degrees Celsius. So that is a change in temperature of, and we will just look at that really quick here. I'm just going to plug that in. 94.4 minus 22.6. 71.8 degrees Celsius is my change in temperature. And it says it requires an energy of 7.06 times 10 to the 4 joules of energy. And the question says if the microwave frequency is 2.88 times 10 to the 10th, and I'm going to say hertz, it's per second, which is the same thing. How many quanta are required to supply an energy of 7.06 times 10 to the 4 joules? So I'm kind of going to separate some of this information. I have energy written down twice there. I mean, it's given to you two different times, but it's the same amount of energy. Okay, so the equation that you're going to use is actually, and I'm just going to put next to the Q there for quanta, N, and you'll see why here. N, H, F is my equation. So energy is my E. My N represents the number of quanta. The H is Planck's constant, which is given to you, and you can write that in your packet if you want to as well, just to have as a additional thing. And then my F is my frequency. Okay, so I'm going to solve. So I'm going to kind of cross off the information that isn't needed. The energy that is given to you twice, it's up there, but we don't really need the mass of the water, and we don't really need the change in temperature. Those were kind of given to us, but not something we needed to actually solve the equation. So we're solving for N from this equation. So if you look at the equation above, we have E equals NHF. So to solve for N, I'm going to divide both sides by H times F. And I can cross off those two on that side. So now my N is by itself. It equals E over H times F. And then I can plug my numbers in. So my E is 7.06 times 10 to the 4 joules. My H is 6.626 times 10 to the negative 34. And then my frequency is 2.88 times 10 to the 10 hertz. And my units are joules times seconds. That's for Planck's constant. and then there for frequency it's hertz, which is per second, which, you know, that's what hertz means. So I'm going to actually enter this on my calculator just to show you kind of how we do this. So if we have 7.06, I'm going to push the second EE button. I'm going to do that again just so you see that 7.06 blue button, and then that EE means times 10 to the, and that's all you have to do. And then I'm going to divide it by 6.626 times 10, or EE, negative 34, times my 2.88 second EE, 10. And I get 3.7 times 10 to the 27, and that represents my quanta. Okay, and the joules cancels with joules, the seconds cancels with the hertz, you know, which is per second, so that's why quanta doesn't really have any units. So that is that. Hopefully that helps with that problem in your homework.